This will be for the Khan Academy exercise, continuity and common fact functions. All right, it says which of the following functions are continuous for all real numbers? So if the function is continuous for all real numbers, okay, it must always be defined. Continuous, we said you can draw it without lifting your pencil. But if there's a point that's undefined, you won't be able to draw it without lifting the pencil. So it must always be defined if it's going to be continuous at all real numbers. All right. So if we look at the first one, g of x equals 2 to the x. Is there any number that x can't be? Well, no, this can be anything, right? 2 to the power of x, the x can be any number. Okay, so that one is fine. That's going to be continuous for all real numbers. But if you look at this one here, f of x equals ln of x. Well, in this case, x has to be greater than 0. Okay, if you go to your calculator and you try to type in ln of 0, it's going to give you an error message because the graph of ln of x is undefined at x equals 0. And really, anything where x is less than 0 would not work either. So this one is not continuous for all real numbers, only g of x. All right, so g only. All right, now they're asking not all real numbers. They're asking us if it's continuous at x equals 3. So if we're only doing x equals 3, it has to be defined at x equals 3. So you just want to take that and plug it in. All right, and see if you can evaluate the function at x equals 3. So right here for this g of x, if we try to evaluate the function at 3, all right, if we evaluate g of 3, that's going to be ln of 3 minus 3. And that is just going to be ln of 0. We just said a minute ago you can't do the natural log of 0, so g of x is no good. Let's try f of 3. Okay, we're just going to plug in 3 in place of x. So that's going to be e to the 3 minus 3, which is just e to the 0, which of course equals 1. So this function is definitely defined at x equals 3. So that means it's continuous at x equals 3. All you have to do is see if it's defined at that point. Really, any point would have worked here, but f is good and g is no good. So just f. All right, once again, we're trying to see if the function is continuous at all real numbers. So in this case, again, you just want to make sure that the function is defined at all real numbers. If you get undefined, then the answer is no. First up, h of x equals log of x. Okay, log, natural log, same thing. The part you're taking the log of, in this case it's x, that has to be greater than 0. Okay, if you try to do the log of 0 or log of a negative number on your calculator, it's going to give you an error message. So this is no good. If it's only greater than 0, that's not all real numbers. All right, g of x equals the cotan of x. If you remember, tan is sine over cosine. Cotan is the reciprocal. Cotan is actually cosine over sine. Okay, and recall when you have a fraction, you cannot divide by 0. You cannot have a 0 in the denominator. But if you take the sine of 0, that's going to equal 0. So at x equals 0, this fraction here is undefined. All right. Because you cannot divide by 0. Okay. And if you do the sign of 0, you're actually going to get 0. So at x equals 0, this function is undefined. That's not all real numbers if the function is not defined at x equals 0. So that one is no good either. Any of these you can graph on Desmos and you'll see. I'll just do the one real quick. All right, so here is the graph of cotan of x. And if I zoom in, you'll see the graph never reaches x equals 0. Okay, it keeps going down. It keeps going down, but it will never reach the y-axis, which is x equals 0. Same thing on the positive side. All right, it keeps going up, but it never reaches the y-axis, which is x equals 0. And that's because, like I showed you mathematically, it is not defined at that point. So neither of these work. None of the above. Neither of them. All right, which of the functions are continuous at x equals 0? Well, we just tested this one, cotan of x. That's no good. We proved it mathematically and on the graph. How about 1 over x squared? Well, if we plug in x equals 0, we're going to get 1 over 0 squared, which is 1 over 0. That is not defined at x equals 0. That's undefined. So that one is no good either. You can't divide by 0. Neither of them. All right, last one. They're asking us if the function is continuous at x equals 2. So let's plug in x equals 2. All right, here we have a fourth root. And if we do 2 minus 4, we're plugging in 2 in place of x. 2 minus 4, that's going to be the fourth root of a negative number. 2 minus 4 is negative 2. If the root is even, the part under the radical cannot be negative. Okay, so this is no good. If this were an odd root, if it were third root or fifth root, then it would work. Okay, but you can't have an even root of a negative number. That's no good. And plugging in 2 right here, we're going to get the log of 2 minus 4. And, of course, that is the log of a negative number. 2 minus 4 is negative 2. You cannot take the log of a negative number. The thing you're taking the log of has to be greater than 0. So neither of these work.